Number 1, is the following compound aromatic? We're going to go through our checklist. First thing is it cyclic? Well, notice we only have cyclic rings. There's nothing that's open or has that zigzag pattern, so yes, that checks out. Moving on to the second part of this, is this fully conjugated with overlapping p orbitals? Well, remember with a double bond, the carbons that are involved do have a p orbital at each carbon. So I can show that just by drawing everything here. And what we're looking for is we want to make sure that there's no carbon here that doesn't have that overlapping p orbital. And we are not going to have that for all of these. So let's draw all these in. Everything's overlapping. So far it's working. P orbital here, all around. So that also checks out. Next is this planar, meaning there's no sp3 hybridized atoms. Well, if I were to look at this carbon, I have 1, this counts as 1, so 2, and 3 electron groups. So 3 electron groups makes it sp2 hybridized. That checks out. I know that pretty much all of these are going to be sp2. We do not have sp3 hybridized atoms. So far so good. And the last part of this is Huckel's rule. Remember that for our double bonds, these are going to count as 2 pi electrons. So let's see how many double bonds or pi bonds we have. There's 1, 2, 3, 4, 5, 6, 7, 8, and 9. So we have 9 double bonds or pi bonds. I'm going to multiply this by the 2 electrons we said were there. That gives us a total of 18 pi electrons. Now I'm going to plug this into our formula for Huckel's rule, which was that 4n plus 2. From there, we're going to solve for n. So I'll subtract by 2. This gives me 4n is equal to 16. Solve for n by dividing by 4 on both sides. N will give us 4. And the main thing we care about is seeing if this is a whole number. It's some sort of integer. We don't have a fraction. So if we have this integer, that does mean that it is going to be aromatic, and it follows that 4n plus 2 format. So our answer here would have been C.